Hello everyone. Welcome to this video on chi-square distribution. I'm Dr. Jubin Anthony, Assistant Professor of Statistics, St. Aloysius College, Edathuram. The objective of this video is to introduce chi-square distribution and to explain how chi-square probabilities and ordinate values can be obtained from the chi-square table. After attentively going through this video, you would be able to refer chi-square table and write the probabilities and ordinate values. The objectives of this video are listed here. This video is structured as follows. First, we define chi-square distribution. Then, the probability density function is given, followed by a detailed discussion on chi-square table. Then a problem involving chi-square distribution is solved. Finally, we conclude with a short discussion on the importance of chi-square distribution. To better understand the concept, the following are required. A clear understanding of the concept of probability distribution is required. Also, a basic understanding of normal distribution is assumed. Please note, chi is a Greek alphabet. How is chi-square distribution obtained? The chi-square distribution is the distribution of the sum of squares of k standard normal random variables. The number of standard normal random variables being summed is the degrees of freedom of the distribution. Therefore, chi-square with 1 degree of freedom, written as chi-square 1, is simply the distribution of a single normal random variable squared. Additionally, chi-square distribution is a special case of gamma distribution. Chi-square distribution is a sampling distribution. Now, let me briefly explain the concept of sampling distribution. Distribution of any statistic is called a sampling distribution. Statistic is any function of a sample. Sample mean, sample standard deviation, etc. are examples of statistics. The statistic which is following chi-square distribution is the sample standard deviation. Normal distribution, student's t distribution, f distribution are some other sampling distributions. The probability density function of chi-square distribution with n degrees of freedom is given by f of chi-square equal to 1 by 2 raised to n by 2 divided by gamma n by 2 e raised to minus chi-square by 2 chi-square raised to n by 2 minus 1. Here, the random variable chi-square can take any value greater than 0. If small s square is the standard deviation of a sample from normal population, then n square by sigma square follows chi-square distribution with n minus 1 degrees of freedom. Now, the shape of chi-square distribution. Chi-square is a skewed distribution. It is skewed towards right. The shape of the distribution depends on the degrees of freedom. In the graph, k denotes degrees of freedom. Chi-square distribution with degrees of freedom greater than or equal to 3 have somewhat similar shape. This is the chi-square table. The top row gives the probability values and the leftmost column gives the degrees of freedom. The ordinate values are given within the body of the table. Here in this example, the probability of chi-square random variable taking value greater than 12.5489 is highlighted. Please note, the probability given across the top is the areas to the right of the critical value. To look up an area on the left, subtract it from 1. The chi-square table for degrees of freedom 21 to 40 is given in this table. Now, a problem involving chi-square distribution. The question is, find k if probability of s square greater than or equal to k equal to 0.05, where s square is the variance of a sample of size 10 taken from a normal population with standard deviation 2. We have n square by sigma square follows chi-square distribution with n-1 degrees of freedom. Here, 10 square by 2 square follows chi-square distribution with 9 degrees of freedom. Probability of s square greater than or equal to k equal to 0.05 implies probability of n square by sigma square greater than or equal to nk by sigma square is equal to 0.05. That is, probability of chi-square greater than or equal to 10k by 2 square is equal to 0.05. From the chi-square table, the ordinate value corresponding to the probability 0.05 and degrees of freedom 9 is 16.9190. That is, probability of chi-square greater than or equal to 16.9190 is equal to 0.05. Now, comparing probability of chi-square greater than or equal to 10k by 2 square equal to 0.05 and probability of chi-square greater than or equal to 16.9190 equal to 0.05, we get 10k by 2 square equal to 16.9190. Therefore, k is equal to 6.7676. That is, probability of s square greater than or equal to 6.7676 is equal to 0.05. Now, why is chi-square distribution so important? The chi-square distribution is widely used in statistical inference. The chi-square distribution is used in confidence interval estimation of standard deviation of a normal population using the sample standard deviation. Chi-square distribution is also used in tests of deviations of differences between theoretically expected and observed frequencies. It is also used to test the independence between categorical variables. Hope now you have understood the basic concepts of chi-square distribution. Also, I sincerely hope now you will be able to refer chi-square table to solve the problems involving chi-square distribution. Thank you.